Hello, and we're going to do 11E. This is nutrient cycles. We're going to talk about various cycles that actually affect life on this planet. And this is officially the last of the official SOL type videos for this class. So this class definitely is waning. So first thing we're going to do is we're going to talk about water cycle. Water cycle, don't know why that happens. Water cycle starts with evaporation. This is when water enters the atmosphere. Energy gets into the water on the surface of the earth. It evaporates, makes water vapor. Remember, water vapor is invisible. You cannot see it. You get it transpiration from plants called bioevaporation. You get respiration from animals. And you also just get most of it evaporated right from water on the surface. Condensation, anytime water goes up, temperatures decrease, relative humidity increases, and eventually you get to the point where water condenses on small little particulates in the atmosphere because water needs something to condense. It doesn't just condense on nothing, it's got to condense on something, and they're called condensation nuclei. But this is actually making a type of water that you can see, and this gives clouds, and I think that's why she drew that blue in there. Precipitation, if these clouds get big enough, conditions are correct, cloud droplets which are small enough to not have a terminal velocity greater than the wind, which is why they stay floating in the air, will actually start falling, tumbling toward the earth. They'll fall through more cloud droplets, they'll pick up more mass, more water, and they'll fall back to the earth. And then they'll accumulate, they'll gather into little creeks, they'll gather into rivers, ponds, lakes, groundwater, soil moisture, and eventually into the ocean. And then at that point, from any point in this accumulation, it will evaporate. So here's a picture of water cycle. I'll start with the ocean where most of the water is located. Sunlight comes down, vaporizes the water, it goes up, it cools, it eventually condenses. This condensed water and cloud formation can move over land, or it could actually rain. Most of the rain falls right back onto the ocean, but it can move over land and rain on the surface. It could actually snow. Snow on the mountains could sublime, which means they actually turn right back into water vapor without melting. They can melt and run off into creeks, and then into streams, into ponds, into lakes. They can percolate into the ground, making groundwater. They can move into the soil, make soil moisture. Groundwater and soil moisture does move downhill just like it does in the stream, just takes a lot longer for it to go, and the deeper it is, usually the longer it takes. And some of those places can pop up into springs, and then we have the infiltration all over this land mass, and we have the water progressively moving into the ocean, and it starts all over. But you can see this cyclic form of water. I will be giving you these boxes in class probably next time, well, actually when we finish the D section, and you can actually just fill these boxes in. It will have the information you see here. So it'll say water pollution, it'll also say acid rain, and then all you gotta do is fill in what the heck is water pollution. Water pollution is the runoff of water that carries chemicals into the aquatic ecosystems. Some of these chemicals are good and needed. Calcium carbonate, needed for the bones and the shells of lots of animals. Silica, same thing. They need other elements, carbon, nitrogen, oxygen. They need the CHNOPS elements, and this is how it gets to the ocean and aquatic environments. But it also carries things that we throw out, oil, gas, other chemicals that we just throw on the ground. Toxic chemicals can kill organisms, duh, and increasing decomposition uses up oxygen by bacteria. So bacteria, in the process of actually doing their breakdown, their decomposition, need oxygen, and what they can do is remove it from the environment for critters that also for other critters that need oxygen, and we'll talk more about that with nitrogen. It's caused by acidic compounds in the air. This is acid rain. Acidic compounds lower pH. Liquid water in the air during condensation. It damages and kills plants because it produces acidic water that falls onto plants, leaves. Actually will yellow the leaves, kill the chlorophyll, making it less likely to eat. and to produce its food so it can eat, and it also changes the soil composition, which can actually lock up some of the nutrients in the soil and make them not able to get into the roots. So acid rain can be a really bad problem. We actually luck out a little bit. We have more basic soil, so it actually neutralizes the acidic soil, but it never hurts to put lime on your yard, so your grass can actually get the nutrients that it does need. Nitrogen cycle, this is basically taking the gas that makes up most of the air, 71%, 78% of the air that you're breathing right now is nitrogen, but life as we know it can't do anything about it, at least most life. We do have some bacteria that live in the soil. We have lightning that actually can fixate the nitrogen, in other words, turn it into chemicals that can be utilized by life. So nitrogen fixation is nitrogen fixing by bacteria. Also lightning, it changes the atmospheric nitrogen so it can be in a usable form for life. Plants absorb the nitrogen right from the soil using their roots. Animals get it by eating the plants. They get their nitrogen from eating, and nitrogen is returned to the atmosphere during urination, and then decomposition by the nitrogen defixation bacteria, and it'll turn it back into nitrogen, molecular nitrogen, N2, which is actually the stuff that makes up most of the air that you're breathing. So here's the picture. The normal cycle is we get nitrogen in the atmosphere, lightning actually fixates it, so it falls down in rain into the soil, bacteria in the soil, and legumes actually have this bacteria living in their roots, which makes it really good for fertilizing the soil. And what farmers will do is every 3, 4, 5 years, they'll actually put soybeans in the soil, then they'll actually cut the soybeans off, and then they'll plow the rest of the plant and the roots into the soil, which would actually put nitrogen in the soil for whatever they're growing, corn or wheat or whatever. But we get this natural process. Plants get it from the soil. Animals that eat plants get it from that. We get it from those animals or eating plants, and that's the normal situation. The organic nitrogen can go into mineralization and actually make nitrates and nitrites, which can actually be utilized by plants. Plant consumption, denitrification, which actually goes, or denitrification, which actually turns it back into gaseous forms of nitrogen. It's supposed to go into the ocean, it's supposed to run off, it's supposed to leach, but the problem is when we actually take this carbon fuel and we pump it into the atmosphere, or we actually put more fertilizer on the land and it washes off into the ocean, we can have all kinds of problems. And so what's the problem with the nutrient cycle for nitrogen? Fertilizer and pesticides. An increase in fertilizer or pesticide use causes an excess form of nitrogen in the soil and water. This causes eutrophication, which basically increases the algae, and you get an algae bloom, and that doesn't sound too bad. Algae produces oxygen, it gives food for critters, but what happens is they use up all the nitrogen in the soil, this algae dies, bacteria increase, they decompose, and when bacteria comes in, they utilize the oxygen, and this pulls the oxygen out of the water, which kills critters that are in there, and you can have fish kills because of this algae bloom, because we're using too much fertilizer. Most people, me included, for a long time would look at fertilizer and say, well, okay, you put it in this particular spreader and you put it on a 2 and that's what it says. Well, why don't I put it on a 4 and I can get twice as much on there, since this is what the plants want? Well, the problem is the plants can't utilize it fast enough, and the next rain takes that nitrogen and washes it into the creeks, and that actually causes algae blooms and decomposition. When algae blooms, then algae death kills, and then decomposition bacteria come in and they use up all the oxygen, and then it's bad for all the rest of the life that's out there. Carbon cycle, we need carbon. It is the one that actually makes organic chemicals. Photosynthesis, plants use carbon to produce glucose. They need CO2 to make C6H12O6. Respiration, animals use that glucose, plants too. They respire, and I don't know why it just says animals, it should say critters, because it's plants also, use the glucose to actually release the carbon dioxide which is the CO2, which can go back into the plants to get turned into more sugar. And it's supposed to be a really cool cycle, but what we end up doing is we end up cutting down the plants and we have an increase in the animals. We're actually messing up this system as well. And then to boot, we take fossil fuels, which are supposed to be stores of carbon dioxide, and we burn them, and we change the oil and the coal into carbon dioxide, increasing the carbon dioxide in the atmosphere, which I will show you toward the end of this video. Carbon cycle, atmospheric carbon. What's supposed to happen is carbon goes into the ocean, carbon comes out of the ocean, carbon goes into the plants, carbon goes out of the plants. Carbon gets stored in limestone and dolomite from the carbon in the ocean. These are the expelled shells of the dead critters that accumulate at the bottom. They get compressed in rock and then they get put up higher, and they're actually limestone. It gets stored in coal and oil and gas. And this is the way it's supposed to work, although what we do is we take this limestone and dolomite and we put it out on the surface to compensate for the acidic, and it actually pumps up carbon dioxide. We actually have acidic rain, so if this is in mountains, in the Appalachians and the Rockies, it actually neutralizes the acid rain, which is good for the life, but it produces more carbon dioxide for the atmosphere. But the big thing is that we're pumping out the coal, the oil, the gas, the natural gas, and we're producing fossil fuel emissions of carbon dioxide. So we're actually increasing the carbon dioxide in the atmosphere. What's the problem? Well, oil, gas, coal release produces large amounts of carbon dioxide when it's burned. Carbon dioxide traps heat in the earth, creating a greenhouse effect. And deforestation, cutting down the trees, which actually are supposed to use the carbon dioxide, actually releases carbon dioxide when we burn the wood. And instead of it actually being pulled out of the atmosphere, it's going into. So here are the present day carbon dioxide, and you can see it's up around 400. Actually, it looks like it's a little below 400, but the present value of carbon dioxide is 404, almost 405 parts per million. Doesn't sound like that's very much, but if we take a look at our sample, that's not what I want. We take a look at our sample, you can see 400 is actually much higher. You can see it does swing up and down and up and down and up and down, and we do get some high peaks and some low peaks. It goes down, looks like the lower number is increased for a while, then it starts going back down. But the problem is now, in the last, let's say 30 years, I'm sorry, this is thousands of years, the last 30,000 years, it looks like the carbon dioxide went up like normal, and then here comes us, and we have actually pushed it up to the top. If you want to see the current values, this is Earth Null School, and I've shown this before with other things, but this is the carbon dioxide, and if you take a look at it, the place where this is actually, I don't know where this is, 54 north, 44 east. Oh, it's right up there. So that point right there has actually got 412 parts per million in terms of volume. You can see there are low pressures, counterclockwise flows. There are high pressures. Where's the clockwise? There's got to be clockwise in there also, but most of the really good storms lower are there. Down here you can actually see clockwise storms. Clockwise storms are the same as counterclockwise storms up here. But if you take a look at these red numbers, like down here in the rainforests that we talked about in the biomes, values are 385, values of 379, and then you go to the lighter colors, values of 408. You go to the greener colors, there's 413. We're about right here. Our value is 318. You can see it's even higher in the industrial areas. So this is the present value of carbon dioxide in our atmosphere. And this is Earth Null School, but all you have to do is, and I'll put these links down at the bottom of this video. And that is it. That's it for 11E. That's it for Unit 11. And other than human anatomy, that is the end of the class. Oh, and our dissection, which we'll do later in May. All right, thanks for stopping by. Adios.